Okay, thank you for the kind introduction and welcome, good afternoon, ladies and gentlemen. My topic, innovative bonding solution for PV mounting system, key for efficient module production and long-term module quality. Okay, having a glance about what I wanted to speak about. It's about the experiences in structural bonding from several other industries, the technology transfer to the PV industry, the several advantages of bonding technology, and the comparison of the different technologies, and finally the standards and certification required for bonding. Okay, bonding. First, for some people it's still a black box, but it's not. It's a proven technology. For instance, for the automotive industry, we introduced the bonding technology in the 1970s. As well, for the facades, it's a well-proven technology. You see skyscrapers all over the world using bonding technology for the glass facades, and other application fields like rail and transportation, and as well marine show that bonding itself is really proven and doesn't contain risk if everything is considered rightly. In the PV industry, when we talk about structural bonding, we mainly talk about back rail bonding and as well fixation elements like the Schletter OptiBond system. And for thin film modules especially, this is the best way to fix modules to substructure or facets or whatever you like to do. However, there is still a lack of knowledge, and the technology transfer from other industries can help to overcome the lack of knowledge. I talk about the bonding know-how itself, for instance, from the facade business, and of course the process know-how. There, especially the automotive industry, has really a long-term experience in highly automated processes. When we can bring this knowledge from both sides, process and bonding, to the PV industry, we can help them to gain further cost savings and long-term module quality. Bonding materials are always process materials. However your production process looks like, there we can find the right solution for your process. That means the curing and strength development definitely fits your cycle times, and also there are high strength, high green strength adhesives available. They could help you to save the prefixation with tapes or something like this. You just stick it together, and you directly can package it, or flashing or whatever. It's done after a bonding process, and if it's considered rightly, no issue at all. We find a solution for your current process. As well, the savings in mounting time. Normally, when you have glass, you know it's a quite brittle material. It's not possible to drill it, so you always need to fix it from the edge, which requires a lot of single fixation elements. With bonding solutions, you can mount innovative mounting systems to the back, which doesn't require any additional consumables like screws, clamps, or something like this. A further disadvantage of clamping systems is the stress concentration at the edges. The brittle material glass normally breaks from the edge into the middle, and it always starts at the point where the stress concentration is the highest. And with bonded solution, you have a quite even load distribution. You have no stress peaks or very low stress peaks compared to the clamping at the edges. And as well, the elastic bonding provides higher safety when it comes to dynamic loads due to wind. You have a better damping and the compensation of the different elongation of the multi-material system like PV systems. As well, the freedom of design. With bonding, you can hide your mounting elements. You don't have visible elements like it is for clamping. It gives the opportunity to architects that you really have a nice appearance of the building envelope and no visible mounting systems. Comparing the different technologies, bonding technologies, shows when we have a look at the PV relevant parameters that silicones is the most preferable solution. Here I compared the silicones with organics like PUs, for instance, acrylics, and as well the tapes. Thanks to the resistance of silicones, you have no issues with UV. It's more or less chemically inert, the silicone, which is not the case for organics and tapes. As well, the performance at different temperatures. Silicones have the best performance. There's no matter if you have very low temperatures, like this up to minus 40 degrees, or if it's above 80 degrees, the actual mechanical performance is the same, and you have no drop of strength at high or low temperatures. Same with weathering resistance. Silicones are, compared to the others, very, very, very weather resistant. Further, the requirements for construction systems, you have different standards to meet. For Europe, it's the OTA-ATAC. Silicones are the only technology that meet these requirements. There are few tapes, or there were few tapes available, but for some reasons they are not really existent on the market. And thanks to the wide adhesion range, the need for primer pre-treatment is not existent for silicones. You just have regularly just have to provide a clean surface, dust-free, oil-free, and there's no need for special primer pre-treatment as it normally the case for organic and tapes. Further, the temperature resistance and the flame retardancy is as well for silicones not a big deal. For the other, you definitely need some flame retardant additives to match these requirements. Next point, the tolerance compensation is an important issue. With the pasty systems for silicones and organics, you easily can compensate the tolerance you have. Normally, after laminating, you have over a meter of the PV module. You have tolerance roughly of 1 millimeter, and the backrail systems as well have tolerances. Worst case, if they add badly, then you have gaps you have to fill. And for tapes, you need a defined pressure to assure a defined and consistent adhesion to the substrates. The processability, I guess, this is equal for all types of adhesives. There are processes available, and depending on your requirements, you can choose between silicones, organics, and tapes. You see, silicones are the favorite adhesive for PV mounting systems, especially when you look at the longevity. As you all know, there are the IEC standards available. The problem of these tests these are system tests only. They don't consider the bonding itself, especially when it comes to the estimation of the lifetime. This strongly depends on the installation side, as the actual conditions are not really considered. You just have a digital test. You have to pass it, but the actual lifetime strongly depends on your installation site. This is differently with the construction standards. These design guidelines have several rules and limitations. for evaluation and for QC and so forth. And most important, a proven safety concept behind that allows an estimation of the lifetime, which is not the case for the IEC. Okay, let's come to an end. To sum up, the bonding to the substructure, the structural bonding, is a major and proven technology, but there's still room for further improvement. This can be done with transfer from the established industries where bonding is used for ages, and bonded constructions have significant benefits in respect of material, process, installation costs, and of course durability, if it's evaluated rightly. And when you have to choose the silicone, silicones are recommended as they match the requirements for the PV industry best and guarantee a long and durable bonding. Thank you for your kind attention. You can address our questions to us. Please visit us, Hall 3, booth F14, and you're welcome to visit us and ask your questions. Thank you.
Some time left for the next presentation. Shall we start or shall we wait? You have 10 minutes additional then.
That was that fast. Oh, dear. Ja, normalerweise habe ich immer das Problem, dass ich viel zu lange brauche. Jetzt habe ich gedacht, jetzt gebe ich Gas.
Macht nichts.
Viertelstunde, ja, Viertelstunde.
So the next